Hello there, discrete math students. As I promised, I am creating another tutorial video for you guys about Haskell. I realize that many of you in the class have no interest in Haskell and you just want to focus on Mathematica. That's perfectly fine, but there have been a few students in the class who have expressed an interest in getting exposed to the basics of Haskell. Okay, Haskell and Mathematica are certainly different, but they do have certain things in common. They're different, but there's a certain amount of overlap. Mathematica and Haskell, they both emphasize the functional approach to programming. There are many ways to program. There's the procedural paradigm, there's the object-oriented paradigm, there's the rule-based or logic paradigm, and there's also the functional paradigm. Mathematica is multi-paradigm, which means in Mathematica you can function in a procedural way, you can program in a procedural way, you can program in a functional way. To some degree, you can even program a little bit in an object-oriented way in Mathematica, although it's not really a true object-oriented language. But you can simulate some of that in Mathematica. Haskell is 100% functional. However, the chief paradigm, the primary paradigm in Mathematica is also the functional paradigm. So Mathematica and Haskell really do have certain things in common. There is an overlap. Okay, so let's get started. I'm going to start my terminal window. It doesn't matter, you could use GHCI or stack GHCI. Last time, in the last video I created for you guys, I used GHCI. This time I'm going to use stack GHCI. It really doesn't make that much of a difference. Stack is just another Haskell tool. Some people really like it, some people don't really use it. If you're a beginner, you don't really need it, whatever, okay? It's at this stage of the game, it's not really an issue. Okay, stack GHCI. Okay, so my window looks kind of cluttered with a lot of information about, initial project files or initializing program files. Don't worry about it. It's not really an issue right now. Colon, exclamation mark, clear. Let me do that again. Colon, exclamation mark, clear. I know that works on Linux and Mac. I'm not 100% sure if that's going to work on Windows. I think on Windows, you would need colon, exclamation mark, CLS. But I'm using a Mac. I usually use Mac. So on a Mac, it's going to be colon, exclamation mark, clear. So 2 plus 2 is 4, 3 plus 3 is 6, 5 plus 5 is 10. Now I want to clear my screen. Colon, exclamation mark. I think on Windows it's CLS. On Mac or Linux it's clear. Okay? Pretty simple and straightforward. I'm going to demonstrate an algorithm that's called insertion sort. Insertion sort. Insertion sort. It's an algorithm. Okay, it's an algorithm for recursively sorting a list of objects that are orderable. Okay, so what is an orderable object? 2 is less than 3. 2 and 3 are integers, and they are orderable. Douglas is less than Douglas, and that's true because in most programming languages, capital letters or uppercase letters are considered to be less than lowercase letters, okay? Therefore, in Haskell, strings are orderable. Now, this is a problem in Mathematica. In Mathematica, strings are not orderable. If you do this in Mathematica, Douglas is less than Douglas, you're going to get an error. Okay, because strings in Mathematica are not directly orderable, which can be a little bit of an issue when you're implementing some string algorithms. I mean, there are things you can do about that in Mathematica, There are workarounds, but it's actually, in my opinion, it's easier to work with strings in Haskell than it is in Mathematica. In Mathematica, you can work with strings. There are functions for working with strings, but it's more difficult because they are not directly orderable. Okay, so Douglas is equal to Douglas. Well, that's easy. That's true. Douglas is less than Douglas. This is going to be false because, like I said, in most programming languages, and Haskell is no exception to this, lowercase letters are considered to be greater than uppercase letters, okay? Right? So actually, we know that Douglas is greater than Douglas because the lowercase d is considered to be greater than the uppercase d. And this is a universal thing with most programming languages. This is not just a Haskell thing. This is a computer language thing in general. Okay? So let's write a function that will sort anything that is orderable. The word that I'm using is orderable. Okay? Any object that's orderable can be compared with the less than sign, the equals sign, or the greater than sign. Okay? So let's see. What's a good example of something that is not orderable? So put_line hello world. Okay, that's how I print something to the standard outputs. So let's see. Put_line hello world. Is that equal to put_line hello world? Okay, so here we're getting back an error message because what we're getting here is related to input-output. So input-output is not orderable. It's not orderable. I'm not comparing numbers or characters or strings. Okay, is E less than, the character lowercase e, is it less than E? Oops, that should be a single quote. Okay, that's going to be false because, like I said, lowercase letters are considered to be greater than the uppercase letters. Okay, so that's false. Okay. Okay, so let's try this, okay? First, let me clear out my screen, colon, exclamation mark clear. Okay, so I have a nice screen, a nice blank screen that I'm working with. It looks lovely. And we're going to try this. So I'm going to enter a whole function here. I start with colon, open the curly Q braces, insert. Okay, I'm only interested, my function will only take arguments that derive from the orderable type class. So here I'm using specific Haskell language. My function insert will only operate on function arguments that inherit from the orderable type class. So characters and strings and floating point numbers and integers, etc., etc. You get the idea, okay? So I have an element that's orderable. It has to be orderable, okay? And I have a list of things that are orderable, and I return a list of things that are orderable. Okay, so the first case is the easy one. I don't know, what should I call my first argument? I could call it A or X or something else. It doesn't really matter. Insert E into an empty list. Well, that's easy. That's just E. I mean, that's very easy. Excuse me. Okay, these are going to be a little more, the other two cases are a little more complicated. Insert E into a non-empty list. And if you have a non-empty list in Haskell, there's going to be a first element and then the rest. The first part of the list and then the rest of my list. And I could call it whatever I want to call it. Okay, I'm going to call it first and rest. You could give it another name if you want to. You could call it head or tail, X and Y, A and B, whatever you want to call it. I'm going to call it first colon rest. You don't have to call it first and rest. You could make up any names you want, but that colon is absolutely necessary. That is absolutely necessary. So the colon separates the first element of the list from the rest of my list, all right? And here there's a condition, there's a guard, and you've seen this in Mathematica. In Mathematica, it looks like that, okay, the / semicolon, but in Haskell, it's going to look like this. So here, what are we going to do if first, here, let me see here, if the first is greater than or equal to E. If first, well, here we have a problem, because what if we have a list like 1, 2, 3, 100, and I'm inserting 99. Hold on one second. So if the first, okay, hold on one second. If the first value is greater than or equal to E, then I'm going to have E colon, or cons, you actually pronounce it cons, E cons, well, now hold on one second. If, you know what, I think I may have, well, here, I'm going to try this. If I mess it up, I can always do it again. I can always repeat it. E first rest. I have a feeling I messed this up, but hold on one second. And then insert E first rest if the first is less than E. Okay, my dog's going to start barking his head off. Let's ignore that. And that's going to be, if the first is less than E, then we're going to have first cons, and then insert E into the rest of the list. Now let's see if this works. It compiles. Now let's see if it didn't compile, I would have gotten an error message. Let's see if it works. Insert 4 into 1, 2, 3, 5. Oh yes, it works beautifully. Okay. For a moment there, I got myself a little bit confused with my greater than and less than, etc., but it works fine. So let's see. Insert 3 into the empty list. Insert 2 into 1 and 2. That looks good. Insert 3 into 0, 1, 2, 100. That looks terrific. Insert, excuse me, how about -3 into 0, 1, 2. That looks terrific. Insert 10 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. And we can see that the 10 is right over here. Terrific. So the function works beautifully. The insert function works exactly the way I want it to. Insert, let's try one more. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's do, actually, there's an easier way of doing that. I could simply write 1 dot dot 11, and I'm going to get the same answer. Insert 20 into 10, 30, 40. Okay, so that looks great. Okay, the insert function is working exactly the way that it's supposed to. I got myself a little bit confused with my less than and greater than, but if I messed it up, if I messed up the function, I could always go back and redefine it. It's not a big deal. Okay, so insertion sort, we're only interested in objects that are orderable. So I have a list of orderable objects and I'm going to return a list of orderable objects. So we start with the easiest situation, which is the empty list, and sorting an empty list is really easy. That's a no-brainer. And if a list just has one item in it, and actually the singleton list, I'm not even sure if I really have to worry about it, because that's really taken care of up here with this case, inserting an element into an empty list. I mean, I could put it in here. That's okay. I don't think it's absolutely necessary. And then finally, the recursive case. First and rest, the first number of my list and the rest of the list. And that's going to be insert first, insertion, sort, rest. And instead of writing it like this, you know what I could do? I could use the $sign. I mean, I have a choice. I could use parentheses, or I could use Haskell's $sign. And it's the same thing. It's totally the same thing. Okay, so let's see if this actually works. Insertion sort 5, 4, 3, 2, 1, 0. Okay, excuse me. So my list is now sorted from the smallest number to the greatest number. All right. Let's try it again with something else. Insertion sort 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1. Okay, and now we see that that's sorted. So let's try to make this a little bit more interesting. Let's work with some random lists. So I'm going to import system.random, and let's create some random characters. Okay. Random characters, let's say lowercase characters. Okay, so I have a list comprehension, random, RIO. Random letters have numbers between 97 and 122. That's a universal thing in computer languages. In Mathematica as well, it's the same thing. That's called ASCII. It's the American Standard Code for Information Interchange. So if you look at the ASCII table, which is universal, the lowercase letter A is equivalent to the number 97. The lowercase letter Z is equivalent to the number 122, and all the other lowercase letters are in between. So 97, 122, one second, and how many letters do I want? I don't know, how about, X is just a dummy variable, don't worry about it, 500 letters, and the type, this particular type is called IO, actually, one second. IO character. Okay, I'm not going to explain why I'm doing this part right now, but trust me, it is necessary. Sequence. I'm getting, wait a minute. IO char. Okay, why am I getting, I'm getting an error. Hold on one second. Random RIO 97 100 char. Oh, you know what? It doesn't. It's not accepting it. Hold on one second. This is irritating. Excuse me. A Z. Okay, so I don't have to use the numbers for this particular case. That's a little weird, but okay. Let me go back here. I'm just going to use A and Z. A and Z. And I believe everything else is okay. Yeah, it actually worked. Yay, okay. So my random characters look like that. Those are my random characters. All right, so I have, a jumble of lowercase letters. I have a jumble of lowercase letters. So sorted random characters is equal to insertion sort random characters. Sorted random characters. Now you can see that the letters are sorted. You can see that all of my letters are sorted from the lowest, which is A, to the highest, which is Z. It's interesting that I just couldn't use numbers to represent. I mean, I understand every system is going to be a little bit different, so that's fine. But normally in computer languages, 97 is the integer that corresponds to a lowercase letter a. 122 is the integer that corresponds to the lowercase letter z, and then you have all the letters in between. Although I guess in Haskell it's not necessary to do that. You can simply use the range a and z. So let's try that again for, random uppercase letters. Random uppercase letters. Sequence, and I'm not going to explain what sequence is doing right now. It basically, what sequence does, well, it's kind of complicated. What the left pointing arrow in sequence does is it takes this input-output list of characters. Well, it takes a list of input-output characters, and it simply changes. It takes the list of input-output characters and changes it into a regular list of characters. Okay, because in Haskell there's a difference between a data type and then the context of the data type. So here, because I'm using random real I/O, the output is in the I/O monad or I/O context, and I have to pull it out of that context. A little hard to explain. That's for another video maybe. So random RI, it's actually not that as complicated as you think, but Haskell has some subtleties. So we can use another letter. Y goes from 1 to 1,000. IO character. And then that leftward pointing arrow changes my list from an IO character list to just a regular character list. Okay, so what does that look like? Random uppercase letters. Okay, so it's a jumble. Everything is out of order. Okay, so I can do this. I could do insertion sort random uppercase letters. And now you can see that the letters have been sorted from the least to the greatest, from capital A to capital Z. Okay, from uppercase A to uppercase Z. And we can store that in a variable if that's what we choose. What should I call it? My sorted list. Okay, my sorted list. There we go. Let's try that one more time. Okay, my sorted list. Okay, so I hope this video wasn't totally confusing for you guys. As I said, I know that in this course we're mainly using Mathematica. I would like to expose you to a little bit of Haskell because I think it is a really cool language. I'm by no means a Haskell expert. It's a language that I have played with on and off for a couple of years. I would certainly love to learn more about the language. It is a challenging language, but I think that's part of the fun. And I really like the logic of the language. And in many ways, the logic of Haskell is very compatible with the logic of Mathematica. Mathematica and Haskell are not exactly the same. You know, there are big differences, but there's a lot of overlap. There's a lot of overlap. For one thing, the list data structure could very well be the most important data structure in Haskell, okay? And also, the list data structure is probably the most important data structure in Mathematica as well. So lists are extremely important in any functional programming language. And Mathematica is mostly functional. It's not exclusively functional, but it's mostly functional. Okay? You can do some procedural programming in Mathematica, but Mathematica is mostly functional. The emphasis is really functional. Haskell is 100% functional. Okay? Okay, that's it for now, guys. I hope this was somewhat helpful to you, and I hope you got something out of this video. Okay, take care. Bye-bye.